Hello everyone, welcome to yet another video on learning BA techniques with examples. Possessing an arsenal of techniques and knowing when and how to apply each technique helps a business analyst carry out his or her work efficiently and effectively. My name is Fatima Suhair and I work as a business analyst at Adaptive US. In last week's video, I explained how to model a data flow diagram. In today's video, I will be taking you through the class diagram. Now, class diagrams are the most popular UML diagrams used for the construction of software applications. They are a graphical representation of the static view of the system, and they represent different aspects of the application. I would be using Adaptive's very own system called GRC Perfect, a governance, risk, and compliance management system developed for the IT and IT-enabled services domain to depict the class diagram. Through this example, we will be learning how to draw a class diagram for the project schedule management module of GRC Perfect. Now, before we get into modeling, let's try to understand the notations used in class diagrams. So let's start with class itself. So what is a class? A class is nothing but a representation of an object or a set of objects that share a common structure and behavior. It's in the form of a rectangle with 3 rows. The top row contains the name of the class. The middle row contains the attributes of the class. For instance, a project class can have attributes such as project ID, project name, start date, etc. Now, the bottom section expresses the methods or operations that the class may use. For instance, you can add a project, update a project, etc. Now, an association acts like a connector. If two classes in a model need to communicate with each other, there must be a link between them. And this is represented by association. Now, what is aggregation and composition? They are nothing but specific cases of association. Aggregation implies a relationship where the child can exist independently of the parent. Let's consider these two classes. Team is a parent class, and member is a child class. If you delete the team, the members can still exist. That's called aggregation. Coming to composition, composition implies a relationship where the child cannot exist independently of the parent. For example, let's consider house as a parent class and room as a child class. Now, rooms cannot exist independently of a house. So that's how composition is done. Coming to generalization, generalization is a mechanism for combining similar classes of objects into a single, more general class. And then finally, we come to multiplicity. The term multiplicity is used to refer to the minimum and maximum number of occurrences to which a class may be related. Now that you have an understanding of the notation, let's get started with drawing a class diagram. The tool that I'm going to use today is called StarUML, which is freely downloadable. So I will be starting with the project class. So I have selected class diagram in the list of models. Let me choose this class. Let me just draw a class. Like I said, the top row is where you name the class. So let me name it project. Here is where you define the methods or the attributes of a class. Sorry, you have to give the attributes in the second row. So let me add some attributes for projects. So I can add project ID. You can think of the different attributes that a project can have. It can have project ID. It can have project name, start date, end date, etc. And coming to the third row, that is where you give the operations. Let me add 2 operations. This is a bit tricky. Okay. We call this add project. And I can also update project. So let me just keep this aside and draw another class called schedule. So what are the attributes that schedule class can have? Schedule can also have an ID. It can have a description. It can have planned start date, planned end date, and so on. If I were to add some operations, I could add a schedule. I can update a schedule, or probably I can even delete a schedule. Okay. Now, how do we connect these two classes? Let's do that by means of a composition. Okay. So this implies that if you delete the project class, the schedule class will no longer exist. Now let me give a multiplicity here. Give a multiplicity of 1. And a multiplicity of many here. This means that a project can have multiple schedules, and if you were to read it this way, it would mean that many schedules can be associated to a single project. The final class diagram for the schedule management module of GRC Perfect would look something like this. We have projects, schedule resources. As you can see, multiple resources can be assigned to a single schedule. We have project allocation, application users. As you can see, a single application user can be allocated to multiple projects, and so on. So I hope this video gave you some insights into class diagrams. In the upcoming video, I will be taking you through a technique called behavior-driven development, which is a great technique for agile business analysts. So stay tuned and thank you for watching.